Harry and Ron want to send a message in class, but they are afraid of Professor Snape will intercept the message. To prevent Snape read their message, Harry comes up with an idea to encrypt the message. He used different numbers to represent different characters. Then the message will be converted to a code of 0 and 1. If Harry wants to say morning, he will send a code like this. Then even Snape gets the message. He still cannot understand what they are talking about. However, Ron meets a problem. When he decodes the first 4 bits of code, he cannot figure out which is the correct one. Because the code word of O is the same as the first bit of R and N. They want you to help them design a method to avoid this condition and encrypt their message into the shortest code. Many people have such experience. Use a kind of other people cannot understand the expression to send private messages between friends. That is why I think this problem may be interesting for non-expert. Computers use a similar method to process data. Mostly, it will convert the data and commands into binary data, then send it to central processing unit. What happens when a computer translates the message? How can it compress a very long message? Maybe a non-expert will ask this after knowing computer does a similar thing. This problem aim is to solve their confusions. I want my video is friendly to everyone, even little children. They do not need to know much mathematical knowledge. If they can count the number of a character's occurrences, and can difference which value is larger and which one is smaller, that is enough. Here is the definition of prefix code. No whole code word in the system is a prefix of any other code word in the system. Let's see an example. In the set of 0, 1, 1, 1, 1, 0, 1, 1 is prefix of 1, 1, 0, so this is not a prefix code. In the set of O, 1, 1, 1, 0, 1, no code word is the prefix of any other code word, so it is a prefix code. Let's go back to solve Harry's problem. We will use a method called Huffman Coding. At first, count each character's frequency of occurrences. M 1 time, O 1 time, R 1 time, N 2 times, I 1 time, and G 1 time. Step 2. Sort them by frequency from low to high. Step 3. Draw the Huffman tree. We pick 2 characters with lowest frequency as a tree's left leaf and the right leaf. Pay attention, every time after creating a new tree, we need to sort the new tree and other elements again. In the example, the new tree constructed by M and O has a new value too, so we move it to the last of the list. Then repeat the same operation on the other elements until we put all the characters into one tree. Step 4. As we want to use binary code to represent characters, set the left leaf 0, set the right leaf 1. Step 5. Get each character's binary code. Remember, read the tree from the top to bottom. Then we get the encode of morning. Why the code is shortest? Take a look at this example. The red, yellow, and blue box means 3 different code words, and they are in the same length. And we place them on a line by their occurrence numbers. Then let's do a little change on red and blue box lengths. Cut a piece of the red box and paste it on the blue one. Our aim is not to change the sum of 3 code words lengths. Place them on a line again. This time the code length is shorter than the first one. That is because we give a code word with a higher frequency a shorter length. This is what the Huffman coding doing. Look the Huffman tree we drew. The character with the highest frequencies code word is shortest. The character with lowest frequencies code word is longest. That is why Huffman coding gives us the shortest code. Why Rowan will not misunderstanding. Look at the Huffman tree. No leaf is other leaf's parent, which means no code word is other code word's prefix. The Huffman coding gives us a prefix code. That is why Rowan will not misunderstanding.